In this video, we're going to discuss static routing and why it is evil, in my opinion. So I've built us a very small, simple network here. We have a LAN in Sacramento. We have a LAN in Charlotte. The traffic has to go through Atlanta to get from Sacramento to Charlotte. And so let's look at how the traffic gets from point A to point B. Let's start with Atlanta because it's got the most complex routing table, actually. So we'll go into enable mode here in Atlanta and we'll do show IP route. And you'll notice that we have two connected networks, which are our two serial interfaces. One's going to Sacramento, one's going to Charlotte. We also have two static routes in here, one for the 10.10.10 network, and it's going to this router over here, 192.168.1.1. And we have a static route for the 10.10.10 network, which is going to 192.168.2.2. This 1.0 network is over in Sacramento. This 10.0 network is over in Charlotte. And so obviously we can verify that traffic does get from Sacramento to Charlotte. First, let's go over to Charlotte and I will verify for you that the IP address that we expect is over here in Charlotte. So we'll do show IP interface brief, which is one of my favorite commands. It gives you a good overview of what's going on the router or on the switch. In this case, you see its fast Ethernet LAN address is 10.10.10.1. So we can go over to Sacramento and enable over here and do ping 10.10.10.1, and we actually are able to ping. And if we do a trace route to 10.10.10.1, we see that it goes to 192.168.1.2, 192.168.2.2, and ends up in Sacramento. Now, all of this works because I have static routes defined everywhere. If we look over here in Sacramento and we do show IP route, Sacramento also knows about the same networks that Atlanta and Charlotte knows about, actually. The 10.10.10, 10.10.10.0, and the 192.168.1 and 192.168.2 networks, except in this case, obviously, the different networks are static versus connected. So we'll look at the commands in each of the routers that sets up these static routes, just so we know how to set them up. So we'll do show run, and we'll do include IP route. And these are the static IP route commands in the Sacramento router. And we will actually enter some of these here in just a minute in our lab once we break our lab. We have IP route 10.10.10.0. In this case, we're saying we want to set a static route in this router using the IP route command. We're setting a static route to this network, 10.10.10.0, with this subnet mask, 255.255.255.0. And this is the next hop router, in this case, 192.168.1.2. That is Sacramento's neighbor router, which happens to be Atlanta. If we go over into Atlanta, we do show IP interface brief over here. We see we have the IP addresses 192.168.1.2, 192.168.2.1. And again, seeing that this is a very small network, this works pretty well. We have our static routes, we know where our routers are located, and so on and so forth. So now let's complicate things just a little bit. Let's say that in Charlotte we have just bought another company and we need to integrate their network into ours. So we have run a fiber over to the next building where the new company happens to be, and we've plugged it into this router. Now, I'm not going to actually bring up another Ethernet interface. I'm just going to assign it to a loopback interface on this guy. So we'll go into config mode. We'll do interface loopback 10. And we'll do IP address 10.10.20.1 with that subnet mask. And now if we go out here and do show IP interface brief, we can very easily see that the Charlotte router now has this network assigned to it. So now that we're using this network on this router, we should be able to ping it from Atlanta, shouldn't we? Well, let's go over to Atlanta, do ping 10.10.20.1. And Atlanta doesn't know how to get the traffic to the Charlotte router, to this new interface on the Charlotte router. And that's quite simply because the Atlanta router doesn't have a route in its routing table. Here's the routing table up here. We know 10.10.1, 10.10.10, and the 192.168 networks. We don't know anything about this 10.10.20 network, and we don't have a gateway of last resort set. We don't have a default route set. So this router just has no idea where to even begin to send this traffic. And again, this gets to the point of static routing of why it's evil, because once you bring up this network on the Charlotte router, you have to go into the Atlanta router and into the Sacramento router and put manual static routes for this 10.10.20 network pointing at the router's next hop. In Sacramento's case, we would say that the route for the 10.10.21 network is actually pointing at the Atlanta router and not over here at Charlotte, because Sacramento sends its traffic to Atlanta, which sends its traffic over to Charlotte. And we'll go back to the network diagram so we can see this. So that means for every network that you add at each of these locations, say we add another network over here, that means we have to go into Atlanta and Sacramento and set manual static routes for this new network off of Charlotte in both of these other routers. If we add a network over here to Atlanta, we have to go into Charlotte and Sacramento and set up those same routes as well. This is on a network with 3 locations. Imagine if you had a network with 20 or 30 locations and you had static routing set for all of your locations. You add a new location, or you add a new VPN tunnel, or you add a new subnet at your data center. You have to go into 20 routers and set 20 routes. And if you fat finger any of those routes, they won't work, and you won't really know why. So this is why I say static routing is pretty much evil once you get above about 3 or 4 routers. It works very well for small networks because, like I said, if you have complete control over all of your routers and all of your switches and you know where all the routes are supposed to go, then you can easily put those routes in there. However, most enterprise networks use a routing protocol, and we'll set up one of those routing protocols elsewhere in this course. But for now, this concludes our discussion of static routing and why it's evil.